Welcome back. We're going to dive into operator overloading today, whereby we add some functionality to classes to make them a little cleaner to work with whenever we want to do some very simple operations. So to get started, we're going to make a star class representing stars in the sky. They'll have some public attributes including brightness and mass. And we're going to overload the plus operator, which means that when we have two star objects, we should be able to say star1 plus star2 and get a star that is a combination of both. So to begin, let us, wrong thing. Give me a text file, include IOStream, use the standard namespace, and here is our question. It would help if I put this in the right folder. Okay, so my class is called star. Got some public attributes. Let's make a constructor, seems useful. So we're going to need a, well, first let's figure out what our properties are going to be. So we're definitely going to want a brightness, which we'll have as a double, and a mass as well. How about just for keeping things a little different, let's make the brightness an integer and the mass a double. So now my constructor is going to need a int b and a double m, and we'll assign those to the brightness and the mass. Okay, so pretty simple here. Let's also get a display function. And our display function will just tell us the properties of the star. Actually, let's give it a name too. So how about we do string name as well. And then display. So the display function of our star will tell us that the star name has a brightness of, let's convert the brightness to a string, and a mass of, and convert the mass to a string. And let's add a new line to the end of it. So let's make sure this works by making a star. If we've messed up already, then we shouldn't go any further. Int main will give me my star, s equals star. I suppose I need to make sure I can assign it a name as well. So let's say string n and give my name an n. So let's make a 500 brightness star with a mass of 40.4, just making up some numbers really. We'll call this one Sol. Let's see if it can display my star. Can I do that? Oops, wrong folder. Let's go into the right folder. There we go. And compile. Everything seems okay. Oh, one moment. Okay. So, since our star class is working, we can go on with the actual question, which is to overload the plus operator to combine the brightness and mass of two stars. And so what we're going to do is we're going to put in here a function called operator plus. And you see operator here turns into big green bolded text because this is a special word that indicates we're talking about when I want to use the plus symbol with two stars. What do I want to do when I make the plus symbol two stars? Well, I want to first of all have another object here. I need to have another star. So I have the current star, but I also want to have a star called the other. And what am I going to return? Well, if I combine two stars together, I should get another star. So we're going to return a star with this. Now, this is probably the sloppier way to write this because I have to now pass a copy of the other star in here in order to have this function work. And I can be slightly more efficient with that by pointing out that in order to that this is probably something I can pass by reference. I don't need to actually pass the whole object, and I'm not going to modify the other star. I'm just going to take them and combine them into a new one. So we are going to, in a single line, write this, which is to return a new star. And our new star is going to be one where the brightness is going to be the brightness of this star plus the brightness of the other star. Similarly for the mass. And for the fun of it, how about the name too? Let's throw a space in there just so it doesn't look as ugly. And now that I have this function, I should be able to do the following. So I got star1. Let's make another star. Let's call this one, I don't know, Betelgeuse. And this is star 1, this is star 2, and then star S3 is S1 plus S2. Real simple. I'm literally just going to take these two stars, add them together, I get S3. Let's see what S3 looks like. Oh, what did I miss? Looks like I missed a brace. So let's fix that. Oh, actually, it's because I missed a parenthesis and a semicolon here. That's what it is. So that hopefully should fix our compilation error. And when we add them together, we get the star Sol Betelgeuse, and it has a brightness and a mass that are a combination of Sol and Betelgeuse. Hooray! All right, that was our first overloaded operator, but there's a lot more we can do. So next up, let's overload the less than, greater than equals, and less than equals. I should flip these, probably a little nicer to look at that way. There we go. For the star class, to compare the masses of the two star objects. Okay. Let's overload some operators. Now, these ones are pretty simple. All we are doing is we're comparing the two things that are there. So we can take exactly what we have going on with this one. And let's just start with the less than first, and then the other ones will actually be nearly copy paste of the same thing, which helps make it very simple. Now, instead of plus, I want a less than. Instead of a star, this is just going to return a Boolean. It's either true, it is less than, or false, it's not. And here, what I want to return, well, I want to see if this mass is less than the other's mass. This mass less than other's mass, that's it. Make sure this works. And I'll output Sol is and then here is where I want to put either not or nothing. More massive than Betelgeuse. I don't need to type these out. I can just say s1.name is something more massive than s2.name and line. And here's the tricky part: is I want to say not if it's not more massive. Or actually, I'm doing less than, right? So I'll say less massive. So if it is less massive, I just want to have nothing here. And if it's not less massive, I want to say not less massive. So how do I do this? Well, one trick is there's actually something we can use called a ternary operator, which means we literally can ask the question of, is it less massive or not? And so literally I'm looking for S1 less than S2. Is that true? If it is, then I will not say anything. And if it's not true, I will say not. With a space here. There we go. So, it is less massive, right? We see 40.4 is less than 140.4. So if this works correctly, we should see that Sol is less massive than Betelgeuse. Let's find out. What did I mess up? Invalid types of so I think the problem here is that I'm attempting to combine a character array with a string, I suppose. So I think there's a typing issue going on here. Let's see if we can simplify this by making a string variable, which is result. So there should be, no, there should be a way to do this a little better. I feel like I've messed something up here. What if I do that? Will that work? No, it's still unhappy with this. Oh, I put in a plus. What am I doing? That's a plus. Should be the arrows. Too busy adding strings to remember I should be sending arrows there. There we go. So this is not necessary. That was just a blunder here. Little oversight. Okay, we're good now. Everything's cool. All right, and it's Soul is less massive than Beetlejuice. And if I do it the other way around and I say I flip them, this isn't quite right, because Beetlejuice is not less massive than Soul. So that means that... Oh, I have to flip them here too. That's why. There we go. And compare S2, then S1. There we go. Beetlejuice is not less massive than Soul. And you can do, whichever way you prefer. Now, we know this works, which means the rest of them are actually very easy. Space them out properly. Very annoying. Fine. Tab, tab, tab. There we go. So instead of less than, I can do greater than. Instead of less than equals. Greater than equals, greater than equals. And then you can do something like same thing. S1 is, and so here let's say I want to do sure, let's do it this way. Well, let's put S1's first, S2's second. And we'll do greater than here and less than here and see what happens. So remember, Soul should be smaller than Beetlejuice. Soul is not more massive than Beetlejuice. It is less massive than Beetlejuice. And there we go. And obviously you can test this with the greater than equals, less than equals, and it should work totally fine. But what did we do? All we had to do was take our operator, change the symbol. We're not returning a star anymore, we're returning a Boolean. And I can just return the answer. And that's it. All right, let's move on. Our next exercise, we're going to overload the minus operator to calculate the difference in mass between the star objects. Then we'll overload the multiply operator to take an integer and create a star that's that many times more brightness and mass. For instance, star times 3 should give us a triply bright and massive star. Okay, so again, we kind of have the gist going on here. So let's overload minus first. That should be easy. So our minus operator, given another star, should tell us the difference in the mass. This means it should return a double, and it's pretty simple. It should return to us the difference in mass. So it should basically be this mass minus the other mass. Let's make sure this works. So let's display all of our stars so that we can actually see them all. So here's all our stars. And there's the massiveness. Let's also output the difference in mass between and 2 is, and I need to convert to a string. Also, let's space this out so it's a little easier to read. S1 minus S2. Let's see if that works. Compile number 3 and go. So we should add a space to the end here. That's the first thing I noticed, but let's look at our results. So I can compile it and run it again, I suppose, to make it a little cleaner. Compile, go. Okay. So Sol is mass 40, Betelgeuse is mass 140, and Sol Betelgeuse is mass 180, with some decimals in there. Sol is less massive, and the difference between them is minus 100, and that looks about right to me. 40.4, 140.4, they're 100 apart. Hooray. If you want to, you can obviously work out how to convert the result to an absolute value, but I'll leave that as an exercise for the viewer. Now we want to make a triply, or whatever much we want to multiply by, star. So here we're going to do a similar thing to over here. Now we're looking at a operator multiply, and we're not taking a other star, we're just taking an integer multiplier. And here we're going to return a star, but instead of adding things together, we're just going to multiply by the multiplier. Now, we can't multiply the name because this is not Python. So let's say that we did want to do what Python does. When Python, if we multiply a string by a number, say 3, we get the string 3 times. So let's actually do that, but we'll need a loop. So for I is 0, I less than multiplier I plus plus. Let's make sure we have our base name, which is the original name. Or I guess our base name can be empty string, and then for this many times, base name, or sorry, not base name. This is the new name of the one that we're building, and it's going to simply add the name of this star, and it's going to keep doing that for however many times they're there, plus a new string, a space. Sure. Now instead of multiplying, I can just return the new name. So let's see how this looks if we make a bigger Sol. So let's say star S4 equals S1 times 5. And then we'll do S4.display. Clear, compile, run. So we have Sol, 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 Sol. Now this space, maybe we can figure out how to deal with that. But it has a brightness of 2500, which is 5 times the original brightness, and a mass of 202, which is 5 times the original mass. Can we work out how to get rid of that space? Probably there are some things that we can think about. First of all, I only want to add a space if I have gone past the first name. So what I might want to do actually is have the new name be this name, and our loop will go starting from 1. And instead of having the name plus the space, we'll have the space plus the name. And I think that should solve our issue. Let's try it. There we go. Oh, hold up. It's not this name in quotes. It's it's this name. There we go. Sol, 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 Sol. All the spacing is proper. Now this does look like it will fail for 0. So perhaps it's the case of, I want to say, if the multiplier is 0, return a star with 0, 0 empty string as the name. But that's only if someone decided for some reason to do that. And clearly this will not work for negative numbers. You can work out, I suppose, how you feel like handling that. But now if someone makes a 0 multiplier star, it's just basically empty. But otherwise, we assume they have at least one instance of the name of the star we're multiplying. We will construct its name by adding that name over and over and over again. And then when we return it, it will have the multiplied brightness, mass, and the new name. Okay, on to our last one. So for the last one, we have to do some tricks here, because with this exercise, we want to overload the arrows operator. And the problem here is that we can't just simply put this inside of our class as a member function, because when you look at every time we've printed something out, what is on the left is something like cout, or another string sometimes. But every time that we've been using our overloaded operators, plus, greater than, minus, star, you can see that the class is always on the left. And so in order to manage this, we are going to need to write a function outside of our class. Now, this is going to have a very weird looking return type, which is, so what is, when you do cout with arrows, what does it return? And the answer is, it returns a reference to an output stream. So the return type of this is ostream with an ampersand, and you can also put the standard in front of it, because that's required if you don't have the namespace thing at the top. The operator is these two arrows. One of the parameters is another one of those output stream references. We'll call it OS. Remember, this could be cout, but it also could be a file. There are some other types of streams that could be as well. And the second parameter, the thing that comes after the arrows, is going to be our star. And here, once again, we can pass it as a constant reference to our star. We'll just call it S. Okay, and what happens when we want to print out a star? Well, probably what we want to do is we want to basically do what display is doing, which is we want to send all this stuff to the appropriate output. So what I'm going to do is I'm going to take this, but instead of cout, we're going to use OS. And instead of a void function, this has to return the output stream. And so what I've done here is I've told the computer, hey, whether it's a file, a cout, whatever it is, send it all of this information if you try to print out a star. And now the magic of this is I can do the following, is instead of saying s4.display, I can just say cout s1. Actually, I can do it all in one go if I really want. Sure, why not? S2, S3, S4. Let's see what happens. Oh, I forgot to put this in a new file. That's my mistake. In fact, I even forgot to copy the question over. All right, let's quickly. So we'll put this here, and we're going to take all of this, and we're going to save this as a new file, example4. And this, I need to revert to the old version that didn't have my function. Got so excited about going ahead that I forgot to to open a new one. Okay, so that was our old one. Here's our new one. Let's see if it works. Boom. Oh, what did I mess up? Oh, yes. So name, brightness, and mass inside of my function here. I can't just say name, brightness, and mass, because I have to refer to a particular star. Well, we have one. It's this one. S.name, S.brightness, S.mass. Okay. And now you can see at the bottom, we output all 4 stars simply using cout. So rather than having to deal with the display function, which is rather clunky to be honest, you can see it's like kind of messy to have to write s1.display, s2.display. Instead I can just send them all to cout, and everything shows up as I want. So that wraps up our exercises. Thanks for watching, and I will see you in the next set of videos where we will continue working on our stars. I'll see you then.